this exercise we'll be looking at a question which is about sequences, and then you also need to apply some skills that you learn in the topic of algebra. So remember, we also provide these exercises compiled together in the form of a booklet, so don't hesitate to contact us so that you can do the exercises on your own before you watch this video solutions. All right, let's let's move on with the question. So we're told that the grid shows the first 3 diagrams in a sequence, and then each diagram is made using small squares that are white or gray. So this is the diagrams which form this particular sequence. So we're told that, or rather the first question says, on the grid draw diagram 4. So if you look at how the first diagram, the second and the third have been drawn, we can see that this is a 2 by 2 box, and then this is a 3 by 3 box, and then this is a 4 by 4 box. So obviously the fourth diagram will be a 5 by 5 box. So if we count 1, 2, 3, 4, 5, so that means this is 1, 2, 3, 4, 5, and then going upwards is 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, 5 is here. So let's complete the box. So this is what we should draw for diagram 4. All right, and then for the shaded boxes, the smaller boxes that are shaded, you can see that it's the top boxes that are shaded, and then the boxes on the right. So we'll have to do the same thing here. So that will be all for number A. Now we're also told write down the term to term rule for the number of gray squares. That is, term to term rule simply means what do you do to get the next terms in the sequence. That is, what do you do to the previous term to get the term that will follow that particular term that you are looking at. So we can see that we have three gray boxes here, and then here we have 3, 4, 5 gray squares, and then here we have 1, 2, 3, 4, 5, 6, 7. We have seven gray boxes, and then here we have 9 gray boxes. So the term to term rule, as you can see in the first diagram, you have 3 gray, the next diagram 5 gray, the third diagram 7 gray, and then the fourth diagram 9 gray boxes. So as you can see, from 3 to 5 you add 2, from 5 to 7 you add 2, from 7 to 9 you add 2. So the rule, just write add 2. That is, you add 2 to the number of gray boxes that you're looking at to get the next number of gray boxes that will be in the following diagram. Okay, let's move on to number C. So for number C, this table shows diagram number, that is diagram number 1, 2, 3, 4, and diagram number n, that is whatever diagram number. So on the second row we have number of small white squares. This means in the first diagram we have only white square, in the second diagram 4 white squares, and then in the third diagram we have 9 white squares. And then this row, the third row, shows the number of small gray squares. So in the first diagram you have 3 gray squares, the second diagram you have 5 gray squares, for the third diagram you have 7 gray squares, and then the fourth row shows the total number of small squares. That is the the total number of white squares plus the total number of gray squares for each of these diagrams. So we are told to complete the table. So as you can see here, the number of white squares, it's 1 in the first diagram, 4 in the second diagram, and 9 in the third diagram. So also know that each of these in each of these 3 rows, the numbers here, the 1, 4, 9, 3, 5, 7, 4, 9, 16, they make up a sequence. So as you can see, this is a sequence of square numbers in this case. And then what we're actually squaring is the diagram number. As you can see in diagram 1, 1 squared, that will give us 1. Diagram 2, 2 squared, that will give us 4. Diagram 3, 3 squared, that will give us 9. So for the number of small white squares in the fourth diagram, that will be 4 squared, which is 16. And then in terms of n, remember n stands for diagram number. So to get 1, 4, 9, and 16, we are squaring the diagram number to get the number of small white squares that will be in that diagram number. So that means for n here, we'll write n squared. That is the diagram number. We square it to get the total number of white squares in that diagram. Alright, let's move on to this row of small gray squares. So we have three small gray squares in diagram number 1, and then we have 5 small gray squares in diagram number 2, and then we have 7 small gray squares in diagram number 3. So from what we did earlier, when we're trying to draw the fourth diagram, and also when you try to answer number 2 to find the term-to-term rule for the number of gray squares, we noticed that we were adding 2 to the diagram number that we're at to get the next number of gray squares in the following diagram. So we know that we got 9 here. So as you can see, there's also a sequence. As you can see, we have 3, 5, 7, 9, and remember the rule was add 2 to the number of small gray squares that you are at to get the number of small squares in the following diagram. So this means this is an arithmetic sequence. So an arithmetic sequence is a sequence in which you add or subtract a constant number, but the same number, to get the following numbers in the sequence, or rather to get the following terms in the sequence. So remember the formula for finding term number n of an arithmetic sequence. It's Tn is equals to T1 plus D times n minus 1. So this D is what is called the common difference, which is the number that is being added or subtracted to get the following term in the sequence. So T1 is the first term in the sequence. So in this sequence of small gray squares, 3, 5, 7, 9, the first term in that sequence is 3 plus the common difference, that is the number that is being added in this case, which is 2. Multiply that by the bracket of n minus 1. So simplifying this, we get 3 plus 2 by n, that's 2n. 2 times minus 1, that's minus 2n. So writing 2n first, and then collecting together 3 and minus 2, we get 3 minus 2, which is 1. So the formula for the nth term for the number of small gray squares will be 2n. Let me correct this. 3 minus 2, that's 1, not minus 1. So this should be 2n plus 1. Alright, so for the total number of small squares, remember the total number of small squares is the small white squares added to the number of small gray squares in each of these diagrams. So what we can do here, to get this 4, in diagram 1, which is the total number of small squares in diagram 1, we have one white square and 3 gray squares. So that is 1 plus 3, that is 4. In diagram number 2, 4 white squares, 5 gray squares, 4 plus 5, that's 9. Diagram number 3, 9 white squares, 7 gray squares. Adding 9 and 7 together, you get 16. So in this case, for diagram number 4, that means total number of small squares will be 25. Also know that the total number of small squares also form a sequence. That is a sequence of square numbers, but starting with 4, not starting with the first square number, which is 1. So it's starting with 4, then the next square number 9, the next square number 16, the following square number, that is 25. So we'll write 25 here. So to get the nth term, or rather the total number of small squares for diagram n, since we already have the formula for the nth term for the total number of for the number of white squares in diagram n, which is n squared, and then we also have the formula for the nth term for the number of small gray squares in diagram n, which is 2n plus 1. So what we can do to find the formula for the total number of small squares, we can just simply add these two together, which is n squared plus 2n plus 1. So this will be the formula for continuing this sequence of 4, 9, 16 and 25. Also, we can write this in this way. Note that this is the sequence of sorry, this is a sequence of square numbers. You have 4, 9, 16 and 25. But remember, this is not in the sequence of square numbers. Remember, the first square number is 1, and then followed by 4, then 9, then 16, then 25. So, but then in this sequence, the starting square number is not 1. That meaning this 4 is the square number for 2, or rather is the square number you get when you say 2 squared. This means to get this 4, you can say the next diagram number squared to get the first number in this sequence. Also know that for the 9 is the same thing. 9 is in diagram number 2. So the next diagram which comes after diagram number 2 is 3. But then to get this 9 for diagram number 2, we'll say 3 squared instead of 2 squared. Same thing applies here. To get the 16, we don't say 3 squared, but we say the number that comes after 3, which is 4, we square that and then we get 16. So we can write this in a different way. So that means when you are in diagram number n, to get this sequence, you square the number that comes after n, meaning the number that you square is n plus 1. Let's go over this again. In here, you're in diagram number 2. 2 is 1 plus 1, which is 2, and then 3 is 2 plus 1, and then 4 is 3 plus 1. This means the number that you're squaring is 1 more than the diagram number that you are currently looking at. So as you can see here, we're in diagram number 1, but which is diagram, in this case, the diagram number 1, n is equals to 1. Notice here n is equals to 1, n is equals to 2 here n is equals to 3, and then here n is equals to 4. So instead of saying 1 squared here, we say the n number that comes after 1, which is 2. Meaning, if this is n, the next n, to get the next n, we'll say plus 1. Since this the term numbers, they're actually counting numbers. That is, they succeed each other. Like you have 1, 2, 3, 4, and so on. So this means one other way to write this would be to say n plus 1 and then square that. So as you can see, this is actually a factorized form also of this formula here. Alright, let's move on to the other questions. Alright, for number D, work out the number of small white squares in diagram 18. So remember from the table, the number of small white squares, we'll have to use this formula, the formula for the nth term. That is, if you want to find the number of small white squares, say in whatever diagram number, it could be in the 5th diagram number, the 15th diagram number, the 27th diagram number, and so on. This is the formula that we'll use. So you just take the diagram number and then you square it. So in this case, we have n as 18. So the formula for the sequence of small white squares is n squared, meaning to get the number of small white squares in diagram 18, we'll say 18 squared. So 18 squared, that's 324. So this will be the number of small white squares in diagram 18. Alright, let's move on to number E. One of the diagrams has a total of 900 small squares. Work out the diagram number. Remember, the diagram number in this case it's n, so we want to find n. But then for this sequence, for the total number of small squares in this case, so what we want to do here, remember the total number of small squares, it's this sequence here, this sequence of 4, 9, 16 and 25. It's this one. So what we can do, we can use this factorized form, this one, n plus 1 squared. It will be much quicker to use. So remember, for the total number of small squares, the formula is n plus 1 squared. But then we know that for some particular n, for some diagram number, the total number of squares that we get is 900, meaning we have to solve this equation to get the diagram number, which will give a total number of small squares of 900. So we can square, or rather we can find the square root of both sides to get rid of the square here. So we'll get n plus 1 on the left side, and then the square root of 900, that's 30. And then from there we can subtract 1 on both sides to leave n only on the left side. So say n plus 1 minus 1 is equals to 30 minus 1. So this will give 0. So we'll have n is equals to 30 minus 1, that's 29. That means the diagram number which has a total of 900 small squares is diagram number 29. Alright, let's move on to number F. Another diagram has 43 small gray squares. Work out the total number of small squares in this diagram. So notice that this 43, it's the number of small gray squares, but then we want to find the total number of small squares in this diagram. So what we can do, we can find the diagram number first. We can find the diagram number, but then using the formula for the small gray squares. So remember the formula for finding the number of small gray squares in diagram n, or rather in any diagram number, we use 2n plus 1. But then 2n plus 1 in this case gives 43, meaning we want to find the diagram number in which there is a total of 43 small gray squares. So we just have to solve for n in this equation. So let's subtract 1 on both sides. We'll get 2n is equals to 42, and then this 2 is multiplied by the n, so to leave n only, remember you undo multiplication by dividing, so we'll have to divide by 2 on both sides, so the 2's would cancel, and then n would be equal to 21. So this means in diagram number 21, that is where you will have 43 small gray squares. But then remember what the question wants. It says work out the total number of small squares in this diagram. Remember, the total number of squares is given by this sequence of square numbers, but starting with 4. And then the formula for the nth term, remember, we found it as n squared plus 2n plus 1, or in factorized form, n plus 1 squared. So what we can do here, since we want to find the total number of small squares, we now know that the diagram number is 21, or diagram number 21. So now using the formula for the total number of small squares, remember that's n plus 1 squared. So to find the total for diagram number 21, the total number of squares, we'll substitute 21 for n here. So we'll say 21 plus 1, and then square that, but then first work out what is inside the brackets first. So that's 21 plus 1, that's 22, and then square that 22. So 22 squared, that should give 484. This means our answer here should be 484. So this is all for this question about sequences. So make sure to watch other exercises, or rather the video solutions of other exercises.